Hi, I'm Gary Parker at the ECA. Today we're going to use DesignGenie to look at the different installation methods for cables and how they can affect the cable current carrying capacity. Earlier on I designed this system with several distribution boards. Now I'm going to add a new board, but I'm going to consider the effect on the current carrying capacity of the different methods of installing the cable. In this case I'm going to design a new distribution board and I'm going to design it with a 100 amp load. I'm going to choose my cable and I'm going to choose a open clip direct method. I'm going to say it's going to be 10 meters long and I'm going to choose our type and configuration of cable. On the right hand side of the screen we can see some green fields, read only fields. In this case telling us what our voltage drop is, our load current and our voltage at the terminals. I'm going to use for this example a BS6724 steel wired armoured thermosetting low smoke cable. I'm going to choose one conductor per phase. I'm going to start off with a 4-core 25mm armoured rated at 124 amps. DesignGenie has automatically populated these values here by saying we've got a current carrying capacity of 124 amps with a maximum length of cable of 41.7 meters. DesignGenie has also told me what losses in terms of watts I'm going to see in this cable over the length of its run. 278 watts. Now for a 100 amp load that could be quite a lot. If we had a larger load that could make a large effect on the installation. Now if I change my reference method from cables clip direct to cables in the ground, reference method D, DesignGenie will flag up a warning to tell me that the load current is greater than the current carrying capacity of the cable. So DesignGenie will automatically upgrade the cable size from 25 to 35mm squared. But this has reduced our current carrying capacity down to 115 amps. Something that DesignGenie will take into effect is the ERA method for designing cables buried in the ground. This will almost inevitably give a higher current carrying capacity for cables in the ground than using reference method D. Just by changing the style of the reference method, I've increased from 115 amps to 182 amps the current carrying capacity of this cable. This involves using the ERA method, which is a design practice that was calculated by the Electrical Research Establishment several years ago. This will allow any designer to reduce the cable size and then potentially save costs on a job. I've now reduced my cable size to 25mm squared, which could be a significant saving in cost. Let's try 16mm squared. I can even reduce it down again to 16mm squared just by simply using the ERA method for design. If I now choose my appropriate protective device, we can see there's several in the list that have already been used. I'll stick with a BS88 100 amp device. I can very quickly and very easily design a new distribution board whilst also saving time and money in the cable design. There we looked at some of the options for the installation methods and the effect they have on cable design. I hope that helped. See ya!